All right, so this is question 1, and it has to deal with base units. Remember the learning objective, students will relate the derived units to the base units in the SI system. So all of those are SI units. All of the answer choices are SI units, but they're all derived units. And the question says, which one of those derived units, it doesn't tell you it's a derived unit, but I'm telling you that, it says which unit can be expressed in base units as kilogram meter squared per second squared. Now, while there's only one correct answer to this question, at this point in the year, we can use this question as like a problem study, as a chance to kind of explore all the physics, herein. And then we'll also get to the correct answer, but it will give us a chance to really explore the idea of base units and make sure we know our definitions. So I'm going to go through each one of these, starting with D, because I know that the correct answer is A, because you get to a point where you're familiar enough with the physics that you just have it memorized. You just know that kilogram meters squared per second squared is units of energy, and joule is the derived unit of energy. So the correct answer is A, but let's see how we can sort of prove that. Again, working backwards from D. So we'll sort of disprove D, C, and D, and then show that A must indeed be correct. All right. Watt is the unit of power. That's not a question, but a statement. Watt is the unit of power. And so what is power? Work overtime. Okay, good life advice too. Time and a half. I mentioned the other lab day as I was pushing the cart across the lab, that brought me back to my bartending days. And I can remember clocking in some weeks where I had a lot of hours on the clock, and you clock in, and you that whole day, you're getting time and a half because you are powering. You're working overtime. Work overtime. Power. Time and a half. And you just, like, it made the day so much better. It's like you're getting paid time and a half. What is work? Force times displacement. Start practicing the academic language. You say, oh, I got to go to work. I got to go to force times displacement. I hope I get to power. Hope I get to work overtime. And then you're practicing the academic language, right? And you're helping everybody else, learn it too. Now let's consider the units of these things. I will put units in parentheses. What is the unit of force? Newton. What is the unit of displacement? Meter. What's the unit of time? You really do have to distinguish between units and quantities, because this S is the symbol for displacement. This S is the symbol for seconds of time. So I'm going to make it very clear. All my units are in parentheses. Okay. What is the base unit of a Newton? Well, it's choice B. So let's just kind of give ourselves an equation. So these are quantities in an equation, F equals ma, right? All of these are quantities: force, mass, acceleration. These are the units that we measure these quantities in, right? So units are like how we measure them. These are the quantities that things are measured. So if force equals mass times acceleration, then I could say that the units here are kilograms of mass times meters per second squared of acceleration. So those are all base units, and you can see that's nearly this, right? So I kind of just know, well, a Newton is a kilogram meter per second squared, but that's a Newton meter, right? A Newton meter, right? There's an extra meter. And so that's how I knew, right off the bat, that it's a joule. Again, because I'm just sort of more familiar with it. So let's remember that the derived unit, the Newton, is equal to a kilogram meter per second squared. And so this Newton right here is really a kilogram meter per second squared times this meter over here divided by this second down here. And we put that all together and kind of clean it up. So a kilogram meter squared per cubic second, that's the base unit of power. The watt in base unit is a kilogram meter squared per second cubed. And just like, bless you, I memorized this, these are the base units of energy, joules. The derived unit joule is this base unit. So too will students that study this know that a watt is a kilogram meter squared per second cubed, right? Because they'll know, oh, well, that's energy, and this is just the rate at which energy is converted, or the rate at which work is done, right? So there's just an extra second in the denominator to put there. So you know, a Newton, a joule, and a watt, all very closely related, right? They're just sort of dividing by, you know, multiply by meters to change newtons to joules, divide by an extra second to turn joules into watts. Because a joule per second is a watt, right? It's another way to think about a watt. Power is work divided by time, right? This W is not watt, it's for work. So joules of work per seconds of time is another thing that's equal to a watt, joule per second. All right, Pascal, what is that a unit of? Either stress or pressure, right? They have the same sort of equation, the same definition. So this further illustrates the confusing alphabet soup of first learning physics. Just a moment ago, I said, oh yeah, this W here, that's not watt, that's work. And this P here is for pressure, not pascals and not power. That's a P for pressure. Clearly, you can see the difference. So pressure is force per area. This A is area, this A is acceleration. And so you really do have to clearly define things. And within the context of the equation, it should be clear, like, oh, this P must be pressure because force per area is pressure. But if it's not clear, you need to spell it out. Just write the word pressure out, you know, or just make it clear, right? You don't want to make a mistake confusing like power for pascals, for pressure, work, watts, weight, right? Those are all W's, okay, in physics. We saw Young modulus, E. Well, that's also energy, right? E for energy, E for Young modulus. Like we ran out of letters. All right, so what are the base units of this? We'd have newtons of force per meter squared of area. I kind of just put it over here so it's less cluttered. So a newton, you may recall, was a kilogram meter per second squared. And because it's per meter squared, that meter is going to cancel out one of those. And so the base units of pressure are kilogram per meter per second squared. Again, very similar to kind of this, right? Because these square meters cancel out one of those. So there's one sort of meter in the denominator with these sort of left over from the newton. And so finally, a joule, we got an equation for it. We could say a joule is energy, and energy is work, and work is force times displacement. So you can always kind of think about base units as starting with an equation that relates quantities, and then you got to know sort of what are the base units, what are the either the derived units or the base units right off the bat. Because if you automatically know like, oh, energy is kilogram meter squared per second squared, then you're kind of done. But you can always go, well, I know F equals MA. I remember that M is kilograms and A is meters per second squared. So I can plug that in here. And then the units of displacement are meters. And so we get to that correct answer by taking a Newton of force times a meter of displacement and just plugging in, you know, that for a Newton, we get this. All right, so that's again why the correct answer is A. As you're studying the learning objective, students will relate the derived units to base units. It's okay to spend all the time like we did with a question like this, but as you sit for the exam, you want to answer this question as quickly as possible without making a mistake. And so being so familiar with the physics that you just know, those are units of energy. Joule is the derived unit of energy, A, and you go on to the luminosity question. You don't need to do all of this, right, when you're sitting for the exam, but it is helpful to sort of, you know, remind yourself, because here the question was about energy, but what if it were about pressure or power or force, right? So knowing all of those.